I bought some of these ESP32 devices about a year ago from eBay, and in this video I'm going to show how to set up a development environment and how to program these from a Raspberry Pi. So it's come to the time when I'm going to need to use one of these in a project, and they're incredibly powerful. I mean, the actual specification of what hardware is on board and how much memory is on board for the price is so much better value than some of the small microcontrollers. Although I'd still prefer small microcontrollers for certain projects over these. There's certain advantages, even though there's not much price difference. I mean, a pick might cost £2, whereas this is between £5 and £6. But if you're going to make a lot of the pick projects, then the cost saving is going to be a big advantage. Also, the pick is a lot smaller footprint than this, because you do need some support components. Even if you're going to use this, make your own circuit and place this device upon it, you're still going to need some of these support components for the Wi-Fi and the Bluetooth if you want to make use of those. So this is the ESP32 device which I'm using to develop on, and if I can just get it right, so that it shows you it's a WROOM32, and it's a dual core 4 megabyte flash device, and it's known as DevKit1. When you plug an ESP32 into a Raspberry Pi via a USB cable, it actually automatically comes up with a device in the dev directory. It's TTY USB 0. So you don't need to install any device drivers onto the Raspberry Pi. It should automatically recognize the device. So before I go through installing the development platform for the ESP32 on a Raspberry Pi, I'll just go through some of the resources that are very helpful for downloading documentation on the APIs and things relevant to the ESP32. So this first one is the Espressif site itself. So I'll put all these links in the description so you'll find them there. And it's the Getting Started section. So I'm about to go through how to install it on the Raspberry Pi. And all I've done is I've taken out the bits from this page and just put them into a simple summary. And that's what I'll go through in a second. So this is helpful for essential for installing the development platform. And then the next one on the same Espressif site, under the resources part of the site, in this last line here is you can download API documentation at this point here, and that's extremely helpful to have that in a PDF form on your local system. And then on GitHub, they have their own section where you can download the development platform, and that's part of this process which I'll discuss just after this documentation. And something that makes the ESP32 extremely powerful is it uses this FreeRTOS system, which is an operating system, a very lightweight operating system. So you still get instant boots into your application when you actually run it on the ESP32. So not like Linux on the Raspberry Pi where you have to wait for it to boot. With this FreeRTOS on the ESP32, you boot straight into your application still. There's no sort of waiting for it to boot up. Yet you have the features of an operating system, like you have timers, semaphores and signals and things like that. You don't have to know much about this. You could just program the ESP32 like you program an Arduino, or in fact you can run it in the Arduino IDE. But if you're really into some powerful programming where you want to operating system style of application for a microcontroller, then this actual FreeRTOS actually provides a lot of helpful features of an operating system kind, and you get the manuals and all the reference data off of the resources under books and manuals on this website. So these are the things that I needed to do to actually install the system, and it actually goes very smoothly without any issue. First of all, I only found this out after doing a couple of trial runs. Needed to go into the user bin directory, and in there there's some Python programs, and I renamed. So originally Python, just Python shortcut link there, it points to Python 2, but that's no good for this install. So I just copied that to an old file, so I could always go back to it, although it's only a symbolic link, so it's not a big problem if you delete it. And I set up a new symbolic link to Python 3. So in the text file over here, because I go to user bin, I move the Python to python.old. Then I create a new symbolic link from Python 3 to Python. And then in the startup documentation, which I showed the web page to a little while ago, it tells you to install some prerequisites, CMake and Ninja. So you just make sure they're on the Raspberry Pi. And then I do also this libffi-dev. So when I went through, I had to install this before it would install the development environment. But this may not be the case. It's because I went through the process a couple of times. This may be one of my failed cases where I actually don't need this, but it's probably worth just installing that just to make sure you need it. And then after that, you have to get from. I won't do this bit of the process because it takes a while to download. But you clone from the GitHub when you're online a particular version. So version 4.1 is the current version, I believe. Later on, that's bound to go up, so it's worth looking at the web page to see what the latest version is when you set up your environment. So if you do a git clone, that gets it to your local machine. It takes a little while to do, and then you go into that directory where you've downloaded it. If I just go to where it is on my machine, so it's in my home desktop. I think ESP32, yeah. So I've got some ESP32 files here. So this is where, so when I did the git clone, it created this directory. So if I go into that directory, so this is what you get from doing a clone, and you have a couple of files in here, a couple of script files. You need to be online when you run this. So install.sh is what you run on a Linux system. Install.bat if you've got a Windows system, but as we're on Raspberry Pi on the Linux system, you run the install.sh. So I come back over to my text file, and that takes a while. That goes online and downloads some extra packages and does some install stuff. And after it's finished doing that, it tells you to run this command, and this is B for wherever it's installed to on your system. You may not have to do it. It may have automatically set that up for you, but I had to actually run that manually to tell it this environment variable where the actual GitHub was cloned to, and then you run /export.sh, and you have to run this before you actually. Every time you want to go into development and you open a command window, you have to run this. But you could put this in your bash.rc file or something, so it runs every time you open up a command line window. But I do it manually because it may mess up some of the environment variables you've already got. So it's probably worth just running this each time you want to open up a command window you want to develop ESP32 stuff in. And then down here, I've just this is just part of my project. So I've copied one of their examples and I've built it up into my own project. I've just made a note to myself that it's this kind of hierarchy. You've got the hardware at the bottom, and then you got the CPU, then you got the FreeRTOS operating system, the ESP this kind of framework which they provide to interface with their hardware, and then you got your C application, C or C++ application. I haven't actually tried C++, but their examples are in C, so it's definitely got C, and it recognizes C++ comments, so it probably does do C++. So I'm going to actually compile and upload a application to this device. Now I've already got an application on there which is making this LED flash. What I'll do is I'll take that application and I'll make it flash, the LED flash a bit faster. So on the screen you can see the source code I've got in this window, and what I'll do is I will change the rate of the flashing to be tenths of a second rather than seconds. So if I save that, and in a command window, so there's a program called idf.py which you do to build and monitor and things like that. So if you use the build command, all it does is build the software. Now the first time you run this on a new project, it actually takes about 20 minutes on a Raspberry Pi, but if you're just changing the simple some of the files, it only compiles those files and then rebuilds it, so it actually does it in a few seconds like it's doing here. and you'll see that soon it will have compiled and linked. So it's doing the linking right now, and it's much faster to develop once you get going. But that build command just builds the actual software, but you can also use a command flash, and that will actually build and then flash it to the device. So rather than using the build, I could just use this flash command to actually flash it to the device, and so that'll go through the build, but there's nothing to build, so it should go through pretty quickly through the build, and then it'll flash it to the device, and this LED will start to flash a lot faster as soon as that's uploaded. And so there it is, it's flashing a lot quicker. So that's how simple it is to build and upload programs to the actual device. But there's a few different commands you can do with this toolkit. But the only other one that I'll show in this particular video is monitor as well. So you've got a serial output monitor. So in the code, if you do a printf, you'll see here it's outputting the printf statements on the console. And to exit the console, you type control and then close square brackets, and that exits the console.